Hello everyone, today is part 5 of our little tutorial series, and today we're going to learn how to make an orbit camera that orbits around a player with leafwing. And let me just move this really like this so you guys can actually see the full tile. Yep, like that. Yeah, yeah. Perfect. So anyways, let's just move forward. Let's just get into it, right? Like let's go into the code itself. Of course, as is tradition, all of this code is going to be available to you guys on the GitHub repo right below. And of course, as is tradition, I'm also going to make a link to the maintainer of the crate that we're going to use in this video, which is leafwing input manager Alice, as Alice is one of the greatest developers in Bevy. She's really one of the the go-to maintainers, and she's also deserves a shout out from time to time. Of course, before we get started, let's go to dependencies. First dependency that we're going to use is leafwing input manager. It's the only dependency that's actually important for this video. So I'm just going to show you guys this guy. If you guys want to understand a little more about this crate, what it does, I would recommend that you guys just go on the link below. Don't try to understand it by me. I sometimes get lost. But of course, I'm going to show you guys how to actually use it in live games, But like the inner details, like what is actually happening behind the scenes, I'm not going to enter too much in detail there. Well, let's go to camera. Okay, first of all, it's worth noting that all of our camera logic is on a single plugin. I like to do it that way because I think camera is like a really important entity. If you screw up camera, you basically screw up your game. So it's really top notch that you guys know that. And also because camera has a lot of bugs implied into it. So it's really worth it that you guys pay attention to this guy because if you fuck up here, you're going to have jitters. You're going to have like a lot of trouble on the later stages. Okay, but anyways, let's get started. First of all, we have our client camera plugin. Plugins, as we all know, is basically just a way of adding multiple systems or initializing certain resources that's specific to that type of system or to that type of like mechanic. So in this case, everything correlated to the camera mechanic is going to be staged here. Okay, and so we already did this so many times, and I think on the later videos I'm not going to even explain it anymore. Macro primary camera, as the name implies, is just a marker component. So easy way of grabbing an entity or querying it for it, and that's basically why we use it. Okay, I'm gonna show you guys how we use it, but it's really simple. Not that much of a complex thing to do. Cam info is really more of one of the main interest components because this guy is probably going to increase size a lot as we add more and more features to our camera. But right now he doesn't have a lot of features. He only have like mouse sensitivity, which is basically like how much the camera is going to shift the orbit as we move like this our mouse as we pan him around, and zoom, which is basically if you want zoom in your camera, if you don't want zoom in your camera, that's going to be basically the usage here. Zoom sensitivity, which is basically like how strong is your zoom and how weak he is. And of course, there is yaw limit and pitch limit, which is basically things that are going to avoid like thing like your camera entering to the floor or going to a specific wall or stuff like that. In this case, I mostly only use yaw limit because he really avoids the camera going into the floor, and he's really dynamic because if we just check the transformer of the camera, we can actually make it so he's really big when we are flying or jumping, but when he's down, we can actually just limit him on the ground. So you guys are gonna notice that this guy is really, it's really easy to understand. It's a little mathematically, but you guys know mathematical, but don't worry too much about it. Zoom is just like a major struct. He's going to have min, max, and radius. This is an orbit camera, which means it's going to orbit around something, right? In this case, it's going to be our player. But and of course, that's why we have radius, because radius is actually really important for mathematic operands when it comes to panning our camera around something. Because usually you want to maintain the same radius, you guys get it, between the player and you. And also because we need to actually, I'm not going to enter too much into the mathematical details, but we need to adjust the rotation arc of the camera as like depending on the distance of the player. That's why we need the radius. But don't worry too much about the mathematics, okay? Don't worry about the mathematics. Don't get scared. Everything's going to be fine. Okay, and here we're going to have a new guy. Like, oh, this is not a component. Yeah, this guy actually has an interesting name. He actually has action like. Okay, for those who don't know what action like is, it's just like I would think I would call it an abstraction. It's just gonna tell you like the action that is currently happening happening according to that input. I think that's basically what action like means. So for example, when we're doing this, like this movement, as you can see on your screen with our mouse, we're doing something called panning, which is basically just moving the mouse around, right? And this specific type of action can occur via multiple types of input. So it's basically like a many-to-one relationship when it comes to databases in SQL. But yeah, it's the same expression. So basically, you can have like multiple types of inputs. For example, you can have mouse, of course. You can have gamepad stick, which is going to be another one, and you can have like, for example, tablet movement with two fingers. Like there's multiple types of inputs that usually we don't actually want to care. Like if the user is using like a mouse or like a gamepad, we don't actually care. We just care about the vector that returns. And that's usually what this guy is going to be. It's going to be the abstraction of the vector that is going to be returning. Okay, so of course span is two-dimensional because we don't actually go into the screen as we move the mouse. And zoom is of course like on one dimensional because he's actually just able to do zoom like this and that. So as you can see here, this looks a lot like a scalar value, like a single axis if you think on functions. So you guys don't need to worry that much about yeah, so that's basically it. And of course, zoom can occur in multiple different ways. For example, in console, it's most probable that you're going to have zoom be some kind of button that when you press, you do a little bit of zoom, or you just do like via like this little weird things that you have on the controller. I don't know how you guys are going to do it because it doesn't really matter for me because we are not going into a lot of different input maps right now. This is very on the later stages when we are like probably just finishing the game. Okay, so after this, we have, of course, our plugin implementation for client Clamor plugin. Okay, as we said, it's going to be the centralization of everything that is shown here. And here it's basically it's really simple, really. This is a must-have from the Input Manager plugin. You just do it. You can try to check it while we do it like this. I just add it. I don't really care. It's probably just going to add a bunch of Input Manager plugins. Correlated to leafwing. um so just do this because if you guys don't do it, it's not going to work. Just do it, this guy. And of course we're going to have a span camera system, our orbit and our zooming system, and of course here we usually register our types. And I'm just going to use this because I actually noticed that I forgot to register the type register the type cam info, which is a really important type to have. I actually forgot to register this guy. Here we have like a run condition, but this was on part 3.2 of our little tutorial series. And I think it's 3.2. Yeah, that's part 3.2. And this guy is basically just making so the camera doesn't orbit around where we or clicks or zooms when we are actually on the GUI itself, which as we know is basically this black screens right here. And here we have spawn camera. Okay, spawn camera is really interesting because as you can see here, there is like here is really just like setting up the structures that we saw before. But this guy here is really quite of important. Here we have the input map. As I said before, we actually have many-to-one relationships when it comes to multiple types of inputs to one type of action, right? And as the input maps name indicates, this is basically just going to map every single type of action into a single action, every single time of input into a single action. Okay, that's what he does. So basically, like here we have camera movement zoom. Uh, no, let's work with zoom. We have camera movement zoom, which is going to zoom in and zoom down when we do this movement. And of course, he's going to map the action mouse scroll axis, which is basically this guy right here, right? But he can map other type of actions. For example, if you were on the gamepad stick, he could map like the action of moving the gamepad up. He can do a lot of stuff like that. You just need to add more like arguments like this one. Like you just need to do this and do it, and basically just add the additional like input map that you might want. Of course, I'm not going to enter too much in detail about the enumerations because, as I said before, it's something more on the later stages of our project, and that's why I'm just leaving it here because preparation. You know, it's going to scale. This guy's going to scale a little bit. Anyways, the rest is really simple. These bundles probably in 0.15 is going to be changed, but they're probably just going to become like a single component. So you guys don't need to worry that much about it. Okay, the rest is like the name, which is going to make for a pretty GUI, and yeah, that's pretty much it. As you see here, we have actually a pitch limit, which is basically like how much we are going to be able to move our camera. Right now, it's just like a stable fixed value, independent of whether our player is moving or not. And it's worth noting that we don't actually have a player, so this camera is just going to be orbiting around the vector 30. But when we add like the player itself and have a movement system, you guys are going to see more clearly how this guy works. Okay, so first of all, we actually start with the zoom system, and all this function is going to really do, right, is basically just going to tell you like, hey, like, oh, we move like this. If we move like this and go down and up, how much did we move? And let's just zoom information accordingly, because then Orbit camera is going to consume that zoom information. Of course, guys, you don't actually need to use leafwing here. You can actually use Bev native. I think there are events that actually give you that information. But I'm just using leafwing because, I want to map multiple types of events, and I know that's kind of like a pain, and it becomes very codey when it comes to, Bev native. Okay, so that's why I'm using leafwing. Okay, but this is quite a simple function. There is nothing more into detail here. It's basically scroll if the value differs from 0, because as is stationary, it's going to be 0, and yeah, and basically just clamp if you reach like the zoom minimum or the zoom max, is basically how much you can zoom in or out. It's really not that complicated. Clamp is just the action of like limiting. Okay, like, hey, stay in this value. Okay, so that's basically what we are doing. Okay, orbit camera, way more complex, a little more of mathematics. But just thinking like this: when we pan our camera, okay, so when we do this action, we are going to capture the axis that's returning from this action. So basically, the vector 2 axis, right, that we're returning from our little actions here, or basically like how much did it change, like from here to here? Like that's basically what is returning. Okay, and of course, if rotation delta is different from vector 0, so which means if the camera is not stationary, we're going to check and do the orbit. Okay, I'm not going to enter into the mathematical details here that occur because I don't think it's really important. Just copy this code. That's simple it is. If you guys are following along, just copy this code. This is really functional and it really works well. But it's basically just like it's going to be based on how much we dealt in, how much we in. Just for a matter of time, I would recommend that you guys try to use that little brain of yours and understand by yourselves. Um, so you guys understand what's happening, okay? So don't worry too much about it. It's very mathematical. It can be a little bit of a pain in the ass how this guy works, but like when you look at it for a long time, you're probably going to understand it. That's why I'm not going to waste a lot of time into it. Okay. Uh, but let's try to break it a little apart for you guys so it becomes a little simpler, so I just don't feel guilty. Here we are splitting our vector, our delta rotation into two parts. One correlated to the orbit, which is going to be like this, and the other orbit like this. Okay, and of course delta x corresponds to the order like this, and delta y like this. Okay, and as you can see here, like yaw is going to be like this. We are going to check if we should apply the yaw limit or not. The yaw limit is usually given by radians because it's a quadrant thing, which is a trigonometric thing. And again, there's a lot of mathematics going on here, so I really recommend that you guys just like study by yourselves because it's really good that much. And after that, if you understand like how these guys apply the limit itself, which is this case, as you can see, we like push like a F32, which I think is going to be a pi radians. I'm pretty sure it's going to be a radians radius. Yeah, it's a radian radius. So this is basically like 90 degrees. You can like look really up, but you cannot look really down. That's basically how it works. Okay, and then like this guy, it's basically gonna give the rotation given by the pitch and the yaw established. And yes, that's pretty much how you're going to have the pretty much the orbit done. And later on this later stage is just going to do the zoom radius. I know it's not a really good explanation, but again, I really don't intend on entering mathematical terminology here because it's really not necessary. Just try to understand this code by yourself. I think it's a good exercise and it's going to be really healthy for you. And of course, with ChatGPT, you can just ask ChatGPT. But here, as you can see here, this is going to be the later stages. And here we can clearly see like our pawn limit. Like how see how like it doesn't go more if I just move like this. Let me just like take it like this. See how he doesn't go more? But here he goes 90 degrees, but here he doesn't go too much. We don't have a yaw limit, so he's just not going to move that much. But again, this is really code that you guys need to look into it. Okay, and this is basically going to be the player that we're going to follow. But on the next part, we're going to understand how predicted players work and how to spawn them. And I really recommend you guys follow the next part because this part is all like there's a ton of examples. There is a ton of orbit cameras around. There is even a plugin called Bevy Pen Orbit Camera if you guys don't feel like doing your own pen orbit camera. I recommend you guys do it because on the later stages we're going to do mechanics that don't actually exist on Bevy Pen Orbit, and also because Bevy Pen Orbit is not capable of capturing multiple inputs, which is the case here. So I recommend that you guys do like I did. Just copy my code if you guys don't want to like waste a lot of time. Okay? I'll see you tomorrow. Bye bye.